Okay, I am going to go through this fairly quickly because it's long, but remember, you can always pause and go back if you need to relook at something. The first thing I'm going to tell you to do every time you see a graph is look at what the y-axis is. This one says distance, so we're going to be looking at all of our distance graphs to answer the questions that go along with this one. So it says for one, write down the type of motion is occurring for each section of the graph, and it gives you some examples there. So from A to B, we have this kind of curve. If you look on your note card, that will tell you that it's positive acceleration. That means it's speeding up. This, and I'm going to write both in there. Okay, we have a curved line. From B to C right there, you can see is a straight line. So it's constant. Straight means constant on a distance graph. And it's a positive slope. So positive, constant, which means it's moving away from start, velocity or constant speed. But it's moving away from start. Looking at C to D, now we have a line that curves this way. The other one curved this way. A to B curved this way. C to D curves this way. So it's slowing down. The slope is starting to decrease. That's negative acceleration or slowing down. It's still moving in the same direction, but the slope is getting more and more gradual. Then looking at D to E up here, this is a directly horizontal line. So if you look, your distance isn't changing. It's stuck at 50 there. So if your distance isn't changing, the object is stopped. And then E to F, it starts increasing again. It's a straight line, so it's constant. So it's also constant velocity. Now, it's a very gradual line, so I would say it's moving kind of slower than B to C. Between which two letters is the rate of speed the fastest? So for this, we want to look for the steepest slope. If you look up at your graph, that's from B to C. That's your steepest slope. So between B and C, because it's the steepest slope. The least amount of distance covered occurs between which two letters? Well, that would be D to E, because it's stopped. And then during the total journey, how many total seconds pass when the object is not in motion? So if we look up here, that's going to be right here. So between like 14 when it stopped and 19. So I would say between 14 and 19 seconds. So 14 seconds to 19 seconds. And that's going to equal 5 seconds. Calculate the average speed between letters B and C. Remember, speed is distance divided by time. So between B and C, if you look over here, the total distance, that looks like maybe 41 and 11. So our total distance is going to be 41 minus 11. We're doing our distance on top. So 41 minus 11 meters. I think that's meters. Yep, and then our time between B and C, it looks like is probably between 5 seconds here and 10 seconds there. So if we go back, and we'll do 10 minus 5 seconds. So that's going to be 30 meters divided by 5 seconds. And that's going to give us 6 meters per second. That is our speed. How much distance did the object cover over the whole journey? So it's only going one way because it's always increasing, never decreasing. So if you go to the very end here, how far did it go? I would say probably 55 meters. 55 meters. And calculate the average speed for the entire journey from point A to F. Well, we already know our distance is 55 meters, and let's see how long it took us. It took us probably 24 seconds. 24 seconds to go 55 because we started pretty much at 0. So we will say 24 seconds, and that gives us about 2.3 meters per second. Again, I know I'm going quickly, but again, this is a review. Okay, next part, and this is at the bottom of your page. I squished it onto the paper, so it's the next section, but it's a little different looking on here. So we've got some descriptions of motion, we've got some graphs, and we've got descriptions. We're going to match them up. So if we look, we'll start with graph A here. So graph A, again, looking at what type, these are distance. So graph A, we have a direct horizontal line, which means it's stopped. And so graph A matches no motion, 12. It is stopped. And I'm going to put, because there's no slope. It's a flat line. Or just horizontal line. Graph B, if we look at that, okay, so we've got graph B and F are both straight lines increasing. Graph B is steeper, but it's going to be, let's see, it's going to be increasing. So it's constant, fast speed. So I would say it's 9. Constant, fast speed, fast. So it's a steep slope. We're going to say it's a straight line too. And then graph C up here is a negative slope. So we know it's decreasing. So it's heading back to start. So I would say graph C matches moving backwards, 13. So we've got a negative slope. And 13 says, yep, constant speed. So straight line as well. I'm just going to do some of those. Graph D, looking at graph D, this is our curved line. So that means acceleration. And since, if you look at your slope, down here, your slope's kind of like pretty flat and then kind of medium and then pretty steep. So the slope is increasing, so it's speeding up. So this would be positive acceleration. For an increasing, the slope is going to be increasing as you go. And then graph E here, it's also a curved line, but it's kind of the opposite of D. So this is when, if you're looking at your slope, it's real steep there, so going fast, and then it starts slowing down. So graph E would match negative acceleration or slowing down, so that's going to be 11. And your slope is decreasing. Again, we're looking at distance maps, so make sure you're at the right part on your note card. And then graph F is also constant moving forward, but probably slow speed. So I would say 10. So 9 and 10 are similar, but it's a not very steep slope. But we also have that straight line. Okay. So those are just matching. Here we're matching, but notice our graphs are different. We are now, and I would go through and highlight these, looking at speed or velocity graphs. And so we're going to look at things a little bit different. It helps that this is in color because I know on yours it's hard to see. So we'll start with 14, no motion or stopped. On yours, it's really hard to see that there's a blue line at 0 there. But that's what that one is. So graph A matches graph E. Oh, I guess I'm doing this wrong. Okay. So we'll put we'll do this. So we'll match them up like this, and then I'll switch them. I'll put them over here. So constant positive velocity. So constant would be a straight line, and it's positive, so it's above 0. So I would say that one is A. And then positive constant acceleration. So we need a line heading upward. That looks like B. positive slope. Negative constant acceleration, so straight line, but going down would be D. And then constant negative velocity. So that means it's coming backwards. That means it's below 0. So that's going to be F. And then positive acceleration, but not constant, would be C. And that one's a little confusing. We're not going to probably do much with that. So now I'll kind of match them up here. So graph A matches description 15. B matches 16. C matches 19. D matches 17. And then E matches 14. And graph F matches 18. So I'll give you a second to catch up on those. So okay, now what type of graph is it? That's what we're looking. This says distance, so we're back to our distance graphs. Which runner won the race? That's hard for me to say for whatever reason. Okay, so which one got to the furthest distance they're running is 100. So who got to 100 first in less time? That would be Albert. Which runner stopped for a break? So which one has, remember, stopped on this is horizontal. So that would be Charlie. Looks like Charlie stopped. There's a flat line there. How long was the stop? Okay, well, Charlie started at 8 seconds and went to 13. So we've got 13 minus 8, which is 5 seconds. Calculate each racer's speed over the race. Okay, so their distances were all the same. Remember, speed is distance divided by time. So they all went 100 meters. We're going to divide that by how long it took each of them. So Albert, it looks like 12 seconds. It took Bob 14 seconds. And it took Charlie 17 seconds. So if you divide all those out, 100 divided by 12 is 8.3. I'm going to move this. Meters per second, 100 divided by 14 is 7.1 meters per second, and 100 divided by 17 is 5.9 meters per second. Okay, so Albert's going the fastest. Okay, this next graph. Again, what type of graph? Velocity. So you got to think about it. What do the slopes of on the line for velocity graph represent? This should be written on your card that slope equals acceleration. Okay, what is happening between points B and C? So this is negative because it's below 0, but it's constant velocity or speed. Okay, so they're going a constant speed, but backwards. What is happening between D and E? Well, that's a horizontal line on 0, so it is stopped. Remember, for these, it has to be on 0. What is happening between points F and G? That's going to be a positive constant velocity. So going at a constant speed, but in the positive direction. E and F. Okay, so E and F, we now, right here, have this slope line, which means it's accelerating. Oops. Going faster and faster. Is the acceleration positive or negative between A and B? Ooh, this one's tricky. Negative. It's actually negative from, this one's tricky. So it's negative from there to there, and then it's kind of positive from there to there. So we'll say negative and not worry about that one because I wouldn't ask that on a test. That's kind of confusing. Because it's slowing down as it gets to 0, and then it speeds back up in the opposite direction. Okay. So looking at the distance time graph to the right, what is happening when the two lines cross? Well, in this case, since it's position or distance, remember we're looking at our graph, they're right next to each other right there. Their position is the same, but then it shifts. So in this one, one object is passing the other. Now, yours is black and white, but in mine, the pink one is passing the black or blue one. So we can do like A and B. So one object, which would be A, is passing the other, which is B. That may make it look a little easier. These again, okay. Next one here, we've got more distance graphs. On distance graphs, slopes represent velocity or speed. Again, looking at, this says distance up here. So that's how we know. Which graph shows a runner that received a head start? Okay, so which one didn't start at 0 but started a higher distance than 0? That would be runner 1. Oops, I keep doing that. Runner 1 started 20 meters or whatever that is. There's no label on that. Which runner is traveling with the fastest velocity? So this would be the steepest slope. I would say runner 2. So we'll say steepest slope. Which two runners are traveling the same velocity? So that's going to have, they will have the same slope. Sorry, that's sloppy. And if you look, these two don't have the same slope, and these two don't have the same slope. But if you look, it looks like probably runner 1 and runner 3. Those are about the same slope. And you could calculate it if you wanted. They go, I mean, you could just say they're going 10 meters in 2 seconds, both of them. So they're going from 20 to 30 in 2 seconds. So this one is going 10 meters in 2 seconds. So you could calculate their slope. I'm just doing it by looking because it's pretty obvious to me. So runners, what did I say? 1 and 3. Okay. And is that the end of yours or do you have more? I think that's the end. So we're done. I'm not gonna worry about this very last part on yours. Okay.